Everyone, welcome to Baozi Training Leetcode solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org, and then this is our WeChat information. All right, so today we're going to talk about this problem called find all anagrams in a string. So apparently we're just doing anagrams a lot these days. So essentially the problem is giving you a string and then giving you s and then giving you a pattern. They want you to output all the starting index of the string in s, that is the anagrams of this pattern. So essentially for this one, starting index, CBA, ABC, right? And then starting with a 6, AB, this is 6, sorry, it's BAC and then ABC. So the thought process is actually pretty straightforward. So this, first of all, when you look at this, it looks like a string matching problem, but this is not exactly matching because we know, for string matching, just on a side note, we have, the CAMP method, which is a standard one, and the not standard one, is actually a classic one, but it's very hard to, pretty much if you don't know it, you won't know it. I would doubt if any interviewer is actually going to ask a CAMP problem. It's just not good. And round bin carb method. So this is essentially just kind of like a hash or mod a string value. It's very similar to the concept if you look at our previous ones, group anagrams. Essentially, you have the array of 256 characters, and then we're gonna put a unique string. It's kind of like having the hash code of a string, or like MD5, those kind of method. And well, a very brute force way, if you think about this, is literally for any kind of like the substrings, you will trying to see if these two are anagrams or not. So it's like, okay, if you have CB and ABC, you check whether they're anagrams. You have BAE and ABC, you check if they're anagrams. So if you're doing that, then it's a kind of a brute force way. You will basically have a ON times N time complexity if N is the length of the string, and then the M is the length of the pattern. So that is definitely not optimal, and actually it's kind of obvious that we can optimize this by just keeping a sliding window. It's a very common technique. So essentially you have a sliding window of a fixed length, in this case the length of the pattern, and you have two pointers. One is starting from the end, the other is starting from the, one is starting from the start and the end. And first you will populate. So a common pattern to code this is, so first you initialize two maps to have the two characters, and then you keep start and end pointer and move one at a time. So, and then one of the neat thing is when you don't forget to compare the last element, because the end will be, the index will be out of bound. So normally what we do is, let's say we keep a characters of 256 of the ASCII code, and then you populate this part. So now, so you have target is like this, and then you have your current characters like CBA, and then you will compare, okay, whether they're the same or not. If they're anagrams, great. So just remember, by comparing anagrams, if you have a maximum of 256 array, so it will be just like, it looks like a for loop, but it's a for loop with constant, so that's still constant. So that pretty much you can think about as constant. Okay, they are anagrams. And then what you do is you move, it's like your end will start one character here, and then your start will basically move one character. So now you have, this is your sliding window. You have start and your end, and then you compare this, and then you're doing this, like etc. So one common technique people will use is actually initialize them at the same time. It's like, okay, when you initialize this, so you also initialize this. So actually, your first, when you start here, you actually compare CBA with ABC, and then you start moving forward. So it's like BAE, so that you save a little bit the length of the pattern, the length of the pattern string. So this is normally how you code. So first thing is very good practice to keep a constant as a public static final. And then you do some sanity checks, and also pay attention to if the pattern length is larger than the string length, there's nothing you can do. You just directly return nothing. So you keep two maps. First, you initialize two maps, like I said, so you can going through this two at the same time, and then you can have your start, and then you have your end at the length. So when the length is less than the actual string length, So now you basically for the starting position, you just check whether they're anagrams or not, and then your start, you decrease your start and then you increase your end. But always don't forget, because when your end is at the string length, you still need to do one more comparison. So if they're anagrams, you still need to add it. So this is the for loop with a constant time. So the time complexity of this method is still O(n), because we're only looping the string as like once, and then technically it's 256 times n, but it's still O(n). All right, so that's the problem. It's relatively straightforward. Okay, thanks for watching.